Hi, today's lesson is on inequalities. The two basic symbols that denote inequalities are the less than and the greater than symbol. Let's see a few examples of both. Compare 2 and 5. Clearly 2 is less than 5. So I can write this as 2 less than 5. How about 6 and 3? Well, 6 is greater than 3, so I write it as 6 greater than 3. How do we remember which symbol denotes what? Well, if you look at the symbol, the open end always points to the larger number, and the closed end, the point always points to the smaller number. So, for instance, this is correct, while this would not be correct, because 4 is not less than 0. The way to denote this accurately would be 4 not less than 0. This symbol stands for not less than. How about this? 3 and 3. Well, obviously we know that 3 is equal to 3, so that's easy. But we also know that 3 is less than or equal to 3. That means I can also write this as 3 less than equal to 3. So this symbol, less than or equal to, is a composite symbol. It means either this or this. These two symbols have been put together to make less than equal to. Similarly, greater than equal to. So either greater than or equal to. The symbol is used as a combination of greater than and equal to. If 3x is less than 9, then what is x? So I have 3x less than 9. I can divide both sides by 3 and I'll get x is less than 9 by 3. Or x is less than 3. Let's check our answer. Let's take a value of x less than 3. Let's take 1. So if I take x equal to 1, which is less than 3, then 3x will become 3 into 1, which is 3. And 3 is less than 9. So my choice was correct. Let's take a value greater than 3. Suppose I take a value greater than equal to 3. Let's say I take x equal to 5. Then 3x would become 3 into 5, which is 15. And 15 is surely not less than 9. So I have confirmed that my solution is x less than 3. You've all learned number lines. Let's see how I denote this solution on the number line. So my number line is a line with numbers moving both ways. As you go left, the negative numbers, and as you go right, the positive numbers. And here my solution is x less than 3. So I have 3 here, and all numbers to the left of 3 are my solutions. Note that I've denoted 3 with an open circle because 3 itself is not part of the solution. The solution is x less than 3. So I don't include 3 in the solution and I denote it by an open circle. And all numbers to the left of it are part of the solution. Minus 2x less than 12. Then, same procedure. Minus 2x less than 12. I divide both sides by minus 2. I get x less than 12 divided by minus 2. So I get x less than minus 6. Let's check. X less than minus 6. So let me take x as, say, minus 10, which is less than minus 6. If I put it into the equation, I get minus 2x would become minus 2 into minus 10, which is 20. Does 20 work? Is 20 less than 12? That is the question. No, it's not. So I have a wrong solution. X less than minus 6 is not correct. X less than minus 6, wrong. Let's understand this better. Where have I gone wrong? The issue here is with the negative number. Let's see why that is so. So let's compare two numbers. Let's compare 2 and 5. What can I say about 2 and 5? I can say 2 is less than 5. Let me multiply both sides by minus 1. So I'll get minus 1 into 2 and minus 1 into 5. That means I'll get minus 2 and minus 5. Now let me compare. What about minus 2 and minus 5? Well, minus 5 is less than minus 2. Minus 2 is greater than minus 5. So, this is the correct symbol after having multiplied by minus 1. That's because on the number line, 2 is here, 5 is here, but minus 2 is here and minus 5 is here. So, even though 2 is less than 5, minus 2 is greater than minus 5. So, we need to flip the inequality from less than to greater than if we are changing the signs of both sides. If we are multiplying by minus 1 or dividing by minus 1, or effectively multiplying by a negative number or dividing by a negative number. Whenever you operate with a negative number on both sides, that is, you divide or multiply, and you are changing the sign of both numbers, then the inequality needs to flip. The reason is here. So where was my mistake here? My big mistake was I was dividing by minus 2. I was dividing by a negative number. So my inequality should have flipped. So I should have got x greater than 12 divided by minus 2 or x greater than minus 6. This is my solution. Very important concept. And there's a reason for it. We do not mug up this concept. The reason is explained here. If 2 is less than 5, then minus 2 is greater than minus 5. So the correct answer was E. X greater than minus 6. Easiest way is to check. Take a value of x greater than minus 6, plug it in, and see that you get less than 12. For which value of x is 4x plus 2 greater than 6x minus 8? So here we have x's on both sides. Up till now we had x's only on one side. The inequalities are getting slightly more complicated. Well, anyway, the first step is to get all the x's on one side. So I can subtract 4x. If I subtract a number on both sides, the inequality doesn't change. Obviously, because both numbers are reducing by the same amount. So if I subtract 4x, I'll get 4x plus 2 minus 4x is greater than 6x minus 8 minus 4x. So I get 2 is greater than 6x minus 4x gives me 2x. Now I'm left with a minus 8. Now I need to isolate the x term. So I'll add 8 to both sides. Add 8. So I get 2 plus 8 is greater than 2x minus 8 plus 8. I get 10 is greater than 2x. So far I haven't done anything much. I've just taken the x's on one side and I've taken the constants on the other side by adding and subtracting. Adding and subtracting move both numbers in the same direction, so the inequality does not change. Fine, so I've now got this inequality. To get x, I just need to divide by 2. 2 is positive, so the sign won't change. So I'll get 10 by 2 is greater than x, or 5 is greater than x. Can also be written as x is less than 5. That's my solution. D. Combined inequalities. 1 less than x less than 7. This is to be read as x is greater than 1 and x is less than 7. X greater than 1, that's this part, and x less than 7. That's this part. Both have been written together. So it's these two inequalities combined into one with an and. Let's see on the number line what it means. So I have 0, 1, 2, 7, 8 and so on. So it means x is greater than 1. So I put an open circle at 1. And x is greater than 1 and it's less than 7. So I put an open circle at 7 and I go less than, and x is all these values. X is all values between 1 and 7, but not including 1 and 7. If the inequality was 1 less than equal to X less than 7, then I would include 1 in the solution and I would fill this circle up. The one circle would be filled to denote that X can equal 1 too. Of course, if the inequality was 1 less than equal to X less than equal to 7, then it could equal 7 too. So I would fill up the 7 also, and so on. The other kind of combined inequality is with the OR. X less than 1 or X greater than 7. Let's see what it means on the number line. So it says that, again, I have 1, 2, 7, 8, 9, and so on. It says X is less than 1. So I put an open circle at 1 and X is less than 1, or X is greater than 7. So I put an open circle at 7 and X is greater than 7. So you see, it's the complement of the earlier inequality. This region is left out. X is less than 1 or X is greater than 7. So in this case, there are two disjoint regions that X is permitted to lie in. It's the middle region that is left out. Which value of X satisfies both X greater than 5 and X less than 1? Well, let's just try the values. 3. Does 3 satisfy both? Does 3 satisfy X greater than 5? Is 3 greater than 5? No. So A is out. How about 0? Is 0 greater than 5? No. So B is out. How about 7? Is 7 greater than 5? Yes. But we want AND. Is 7 less than 1? That's the other inequality. No. So yes and no with an AND means no. Both have to be satisfied. All real numbers? Of course not, because 3, 0 and 7 have not satisfied. How can all real numbers satisfy? So no real number must be the answer. E. Let's confirm that no real number satisfies both the inequalities X greater than 5 and X less than 1. Let me look at the number line. So X greater than 5. X greater than 5 means open circle at 5 and X should be here. And X less than 1 means X should be here. So what's wrong? I'm getting the solutions X greater than 5 and X less than 1. No, I'm not. The word here is AND. AND. So X has to be a number that's in this region and in this region. How can that be possible? These two regions have nothing in common. So no solution. So E is correct. No real number can be greater than 5 and less than 1 at the same time. Let's say a word problem. A pulley can handle no more than 1,000 pounds of weight. It is currently holding 5 steel frames that weigh 112 pounds each. Amanda wants to load as many bricks onto it as she can without breaking. So she wants to load bricks onto this pulley, which already has those steel frames to hold the bricks. If X represents the total weight of bricks in pounds that she can add, which of the following inequalities can be used to determine possible values of X? So you have a steel frame. You have a pulley with 5 steel frames and you want to load bricks onto it. Circular bricks in this case, because my drawing skills are so bad. What is the total weight of the bricks that you can add? Well, this entire contraption can take no more than 1000 lbs. It is currently holding 5 steel frames that weigh 112 pounds each. So how much is it totally containing? It is totally 112 into 5, that is 560 pounds of weight it is already taking. So the 1000 lb, that is the max I can take, is already taking 560. And the rest of it has to be made up of bricks, which weigh X. So 560 plus X is what you will put on the pulley, and 1000 is the maximum the pulley can take. So how do I compare these two sides? Well, clearly I can't go more than 1000 because 1000 is the maximum I can take. So 1000 should be greater than whatever I put on the pulley. So 1000 should be greater than equal to 560 plus X. And now you solve for x. Subtract 560 from both sides. So I get 1000 minus 560 will be greater than equal to x. So I get 440 is greater than equal to x. Rewriting it, I get x is less than equal to 440. So the total weight of the bricks cannot exceed 440 pounds. It can be at most 440 pounds. The answer is E. An automobile's gasoline mileage varies depending on the speed of the automobile between 18 and 22.4 miles per gallon inclusive. So its mileage, if I were to write it as a combined inequality, is between 18 and 22.4. So this is how I write the mileage. It's greater than equal to 18 but less than equal to 22.4. And the word inclusive says it can equal 18 and it can equal 24. So I use less than equal to symbols. If x is the distance in miles that the automobile could be driven on 15 gallons of gasoline, then x satisfies. So distance is equal to mileage into gallons. So distance in miles will be miles per gallon into number of gallons. If I fill in 10 gallons of gasoline, then I'll be able to drive 10 times the mileage, because the mileage is the amount I can drive on 1 gallon of gasoline. So if I want the distance, it's m into number of gallons, which in this case is 15. So the distance is 15m. Well, I know the range of m. So if 18 less than equal to m less than equal to 22.4, I can multiply everything across by 15. Since I'm multiplying by a positive number, the inequalities don't switch signs. So I'll get 18 into 15 is less than equal to 15m is less than equal to 22.4 into 15. 18 into 15 is 225 plus 45, that's 270. 15m, and 22.4 into 15 is 336. I just pulled it out of the answer. I didn't actually do it. So this is my distance. 15m is my distance. So here's my inequality for the distance. The answer is C. Look at how C is written. It's written the other way around, but that is the answer. If 2y is equal to 2x plus 8 and x is less than 3, then y satisfies. Okay, a different kind of question. They've told you that x is less than 3 and what is the range of values of y? And y and x are related by this equation. So 2y is 2x plus 8. Now x is less than 3. So from that, I'm going to try to build up to y. And given that x is less than 3, I'm going to try to get to this expression. I need a 2x, so I'll multiply both sides by 2. So I get 2x is less than 6. Then I need to add 8 to both sides, so I'll add 8 to both sides. I'll get 2x plus 8 is less than 6 plus 8. That means 2x plus 8 is less than 14. Now I've got the expression I wanted. 2x plus 8 is 2y, so I can replace this by 2y. So I get 2y is less than 14. Now if 2y is less than 14, I just divide both sides by 2. I get y less than 7. That's my answer. B. So important algebraic manipulation. Starting with an inequality for x, I built it up to an inequality for 2x plus 8 because that's what 2y is. So then I could deal with the y directly. Let's see one more of that type. If minus 2y is equal to 3x minus 5 and x is greater than 7, then y satisfies. So starting with x greater than 7, I need to build up to 3x minus 5. Because that's what is minus 2y. So I'll start with x greater than 7. I need 3x, so I'll go 3x is greater than 3 into 7, that's 21. 3x minus 5 will be 21 minus 5. So 3x minus 5 is greater than 16. I've got my inequality for 3x minus 5. So I can replace it. I get minus 2y is greater than 16. Now I need to divide both sides by minus 2y to get y. So y is less than 16 upon minus 2. The inequality has flipped for reasons we all know. And y is less than minus 8. That's your answer. D. Again, starting with an inequality for x, I built it up to an inequality for 3x minus 5. And then I could do stuff with the y. Absolute value inequalities. Just quickly recall what the absolute value symbol was. So absolute value of 3 was 3, absolute value of minus 2 was 2. It was basically the distance of a number from 0. So 3's distance is 3 from 0, minus 2's distance is 2, and the absolute value measures this distance. So I can say minus 2 is 2, I can say absolute value of 3 is 3. Let's see how absolute value symbols and inequalities work together. Solve absolute value of x is less than 3. Fine, so I'll draw my number line. I'll solve this. Absolute value of x is equal to 3, just to start. So how do I solve this? I need a number x whose absolute value is 3. That means whose distance from 0 is 3. Well, there are two such solutions, right? X can be 3 or x can be minus 3. Both these numbers have a distance of 3 from 0. Minus 3 and 3 have a distance of 3 from 0. Here's the distance 3. I need to solve this inequality. Absolute value of x is less than 3. That means I have to choose values of x whose distance from 0 is less than 3. Well, these are the numbers. These are all the numbers whose distance from 0 is less than 3. If I took a number here, clearly its distance from 0 is more than 3. Or if I took a number here, its distance from 0 will be more than 3. So these are the numbers I'm looking for. What are these numbers? These are numbers between minus 3 and 3. These are all the numbers whose absolute value is less than 3. So that's my solution. Absolute value of x less than 3 means x is between minus 3 and 3. Minus 3 and 3 are the cutoff points whose absolute values are exactly 3. Absolute value of x greater than 2. So first I'll solve absolute value of x equal to 2 to get some grip on the problem. So which are the two numbers whose absolute value is equal to 2? We know those. 2 or minus 2. These are the two solutions for x. So I mark them. These are the two numbers whose absolute values are equal to 2. What about a number in between? Well, a number in between is closer to 0. So its absolute value will be less than 2. And I'm looking for absolute values of x to be greater than 2. So they have to be away from 2 and minus 2. So any point here or any point here should do it. A point here is further away from 0 than 2, and a point here is also further away from 0 than minus 2. So these points have absolute values greater than 2. All these points. So how do I express the solution set? Well, all these points can be expressed as x less than minus 2, and all these points can be expressed as x greater than 2. Note that I want the absolute value to be greater than 2. So I can't take minus 2 and 2 in my solution. Or. So I want either x less than minus 2 or I want x greater than 2. Both these regions have points who are further away from 0 than 2 or minus 2. Note that this is a combined inequality. I can't write it any simpler. It's two inequalities with an OR. Solve 3x minus 1 less than equal to 6. So this 3x minus 1, I'll think of as one entity. Let me just call it y. So I'm going to solve absolute value of y less than equal to 6, where y is 3x minus 1. What's the solution for y less than equal to 6? Well, first I solve y equal to 6. That gives me minus 6 and 6. I know that. Then I want y less than equal to 6. So I know it's all points between minus 6 and 6, because these are the points whose distance from 0 is less than equal to 6. So my solution I know is y between minus 6 and 6. Now I replace y with 3x minus 1. So it's simple. I get 3x minus 1 is less than equal to 6 or greater than equal to minus 6. And now I solve. I solve each inequality separately. But I can also do it in place. So I add 1 to all sides. So I get minus 6 plus 1 is less than equal to 3x is less than equal to 6 plus 1. Which becomes minus 5 is less than equal to 3x is less than equal to 7. And then I divide everything by 3. No inequality switches because I'm dividing by a positive number. So I get minus 5 by 3 less than equal to x less than equal to 7 by 3. And I have my complete solution. So x must be between minus 5 by 3 and 7 by 3 to satisfy the given inequality. So what's the first big step? That complicated expression within the absolute value symbol, that's 3x minus 1, was replaced by y. And I just dealt with y, solved the inequality. Then again substituted back 3x minus 1 and solved two simple inequalities, just algebraically. Solve mod absolute value of x minus 5 greater than equal to 2. So again, I'll replace x minus 5 by y. So I'm solving absolute value of y greater than equal to 2. I know this solution. Minus 2 and 2 are the cutoff points. I want absolute value greater than equal to that. So I want points away from 0. So the solution is y less than equal to minus 2 or y greater than equal to 2. The equal to sign comes in because here there's an equal to sign. It's absolute value of y greater than equal to 2. So these are my two solutions. Replace y by its expression in x and solve them. So y less than equal to minus 2 will become x minus 5 less than equal to minus 2, which becomes x less than equal to 3. I just added 5 to both sides. Y greater than equal to 2 will become x minus 5 greater than equal to 2, which will become x greater than equal to 7. So that's your solution. X is either less than equal to 3 or x is greater than equal to 7. Let me plot this solution. So I get a 5 here, 3 here, 7 here, and I want points greater than equal to 7 or less than equal to 3. Interesting, if you compare it with the original number line here and here, all that's happened is, here I'm 2 away from 0 on either side. Here I'm 2 away from 5 on either side. And there's a reason for this. I have x minus 5 and y was x minus 5. So the difference between x and y is 5. So if y was centered around 0, x will be centered around 5. How many integer solutions does the inequality absolute value of y minus 2.5 less than equal to 10 have? Well, how many solutions does it have? I'm afraid it has infinitely many solutions, but here they're asking for integer solutions. So we have to be careful. We have to count all solutions. So absolute value of y minus 2.5 less than equal to 10. How do I solve this? Well, the easiest way is to try values. I'm going to try to get to 10. How do I get to 10? Suppose I took 13. So 13 minus 2.5 is 10.5. So 13 is too much. So suppose I took 12. 12 minus 2.5 is 9.5. So that works. So when y is 12, it works. But when y is 13, I'm overshot. So 12 is my cutoff. So y equal to 12 works. Y equal to 11 will work because 11 minus 2.5 will be still less. And I can go all the way down to y equal to 0 because 0 minus 2.5 is 0 minus 2.5 is negative 2.5, but I want to take the absolute value, which is 2.5, which is less than equal to 10. So all the way to 0 works, minus 1 works, minus 2 works, and so on. What's the last negative number that will work? Let me try minus 7. So minus 7 minus 2.5 still works because I get 9.5. But minus 8 won't work, because minus 8 minus 2.5 will give me the absolute value of minus 10.5, which is 10.5, which is too much, which is not less than equal to 10. So minus 8 won't work. So you see the solutions are from 12 all the way to minus 7. All the integers between 12 and minus 7. How many are there? Let's count. Go 12 to 1, that's 12 of them. Then there's 0, that's 13. And then go minus 1 to minus 7, that's 7 more. 13 plus 7 is 20. So there are 20 solutions. And the answer is E. A theatre company is auditioning for actors to portray the leading character in a new play. The company is looking for actors between the ages of 20 and 40. Which of the following can be used to determine whether an actor of age A is eligible? So when are you eligible? If you're between 20 and 40. So if A is between 20 and 40. So 20 and 40, and A should be between them. So A should be greater than equal to 20 but less than equal to 40. On a number line, you have 20, you have 40, and A is between 20 and 40. How do I work in the absolute value symbol into all this? So what I'm going to do is, I'm going to try to get the point of symmetry between 20 and 40. That's 30. 30 is halfway between 20 and 40. And I'm going to subtract everything by 30. So I'm going to subtract 30 from every value. So I'll get 20 minus 30 is less than equal to A minus 30 is less than equal to 40 minus 30. Simplifying, I get minus 10 is less than equal to A minus 30 is less than equal to 10. Now I have some nice symmetry because I have minus 10 and 10 on both sides. That's the reason I took the midpoint 30. Now this looks like the solution to an absolute value inequality. Suppose I replace A minus 30 by Y. I get Y is between minus 10 and 10. So Y is the solution of which absolute value inequality? We know that. This means mod Y is less than equal to 10. When absolute value of Y is less than equal to 10, then Y must be between minus 10 and 10. We've seen that a number of times before. So we are done now. Just replace Y by A minus 30. So absolute value of A minus 30 is less than equal to 10. This is my solution. D.